So in the previous two questions, we found delta G at 85 degrees C for a reaction and minus 12 degrees C for a reaction. And we found that at 85 degrees, it was non-spontaneous. And at 12 degrees, minus 12 degrees, it was spontaneous, which again, we found because the delta the delta H is negative, and the delta S is also negative. In this case, the reaction becomes spontaneous at low temperature. Now it says, considering the two questions above, at what temperature does this reaction become spontaneous? So in this case, delta G equals delta H minus T delta S. Note that we are given the delta H and the delta S. But the inflection point where it flips from spontaneous to non-spontaneous is when delta G is 0, right? So at temperatures below whatever we solve for when delta G is 0, it's going to be spontaneous, and at temperatures above whatever we find at delta G to be 0 is going to be non-spontaneous. So now we can plug in our numbers where T is our variable. So if we look at this, the delta H is going to be minus 34.6 kilojoules minus T, which is the variable, times minus 0.114 kilojoules per K. All right, so this is going to be how we're going to do this particular question. Now, what we need to do is solve for T. So the first thing I'm going to do is add 34.6 to both sides. So 34.6 kilojoules equals minus T times minus 0.114 kilojoules per K. Okay, then if you multiply through the two minuses, this becomes positive. So if we just divide by the positive 0.114, because we have a minus times a minus, and divide this by 0.114, we find that T is going to be equal to 304 Kelvin. So at 304 Kelvin is the tipping point. Said another way, at temperatures above 304 Kelvin, this reaction is going to be non-spontaneous, and at temperatures below 304 Kelvin, this reaction will be spontaneous.